Hey, welcome back. This is the homework 4.6. I wanted to just zip through it. I'm not. This video is, my homework videos are kind of optional. There's no like video quiz in here or anything. It's just in case you get stuck in the video homework, you can use this video. And I did the 4.5. If you want me to, do a homework video like this, let me know. It seems like an okay idea, but and sometimes it's helpful for me to go through the problems just to see what you're up against. But anyways, here we are. All right, so this 4.6 now, hopefully we're tangents and secants and all that stuff. So we have the match, apparently, this one. Tan, if you recall, this time has a range from negative pi over 2 to positive pi over 2. And it looks like this in the middle there. So looking at the graphs, it says negative pi over 2 to pi over 2. Let's kind of, I guess, just identify, well, they have two shifted versions. Okay, so tan of x plus pi over 2. It should just be less than pi over 2. Subtract negative pi over 2. Subtract pi over 2 from all three sides. You get negative pi over 2 minus pi over 2, which is 2 pi over 2, which is negative pi, less than x, less than 0. So you should have sort of one of your little curvy things here for that one. Which one was that? That's the first one, right? So let's see if we can find that guy. Looks like it's this guy here. Okay. Yeah, it has to be. All right, zoop. Tan of x plus pi. Well, it didn't work. Get in there. Okay. Tan of x plus pi, so wedging x plus pi in here. Subtracting it from all three sides, you get negative 3 pi over 2, less than x, less than negative pi over 2. And so what does that look like? There's negative pi over 2, 2 pi over 2, negative 3 pi over 2. You're going to have some sort of wedging like this. So going by pi over 2's, pi over 2, there's 1 pi over 2. It's going to kind of just look exactly like what it normally looks like. So I would say that is this guy here. Negative tan x is just going to be this guy here, but then rotated about the x-axis. So it should just go like this and then rotate, and it's like this, right? So it's going down instead of up, and it's going through the middle. So that this guy is this guy. And then by process elimination, this guy must be this last guy. I'm not even going to check. Okay. Choose the correct graph. 2 periods of x over 2. Okay, so the amp is 6, so x over 2, we're in between negative pi over 2 and pi over 2. Multiplying by 2, now we're in between negative pi and pi. And taking a look at it, and you have to this is negative pi, this is pi. So the length of that interval is 2 pi. And then dividing it into 4 parts, you're going negative pi plus pi over 2. Okay, so negative pi over 2, 0 pi, and then 1 pi over 2. So its amplitude is going to stretch it. So the key points, so to speak, there's one here, and then there will be one here. And then it'll just kind of go through like this. Of course, I can never get my concavity correct, but it should look like that. So it's going through the middle, folks. So it looks like it's C. this one's flipped, so automatically it is not C or D. It should be, going through the origin. So does that get rid of any of the other ones? No, not really. Okay. It's flipped upside down. Sorry, it's flipped upside down. So it's not A or B. There's that negative in the front. So it's either C or D. And then it should be going from okay, so the wedging the 1/2 x in between pi over 2 and negative pi over 2, multiplying everything by 2. You see the thing is wedged in between negative pi and positive pi. So on the axis, it should go from negative pi to pi with the asymptotes right there and right here, and then it's upside down, so it'd be something like that. And that looks like it's going to be, well, it is A or B, sorry. I don't know what my brain's doing sometimes. But it's going from, this one has an asymptote at, looks like it's the same as this. They're not different. This one's a little more stretched out though, so the 3 in front of it's going to stretch a little bit, so I think that's the point here. Okay, well, maybe not. I have no idea how I guess you have to zoom in on it or something, and then maybe you can tell it's hitting at 3 as opposed to this guy. Which, oh, this one's going and hitting at 9, so that's the deal. Sorry, folks. So if you look at the amplitude was, what was it, -3, so you know that main point at pi over 2 was at 3 and -3. And if you zoomed in on the pictures, the other one, the reason why that was wrong was because it went from 9 to -9. Okay, let's try this again. So cotan this time is wedged on the interval from 0 to pi. Okay, and so its asymptotes at 0 and pi, and then you have a point here. 1, 2, 3, 4, 1, 2, 3, 4. So down 4, up 4, and try to get my concavity going correctly. Okay, so it should look like that from 0 to pi. So the first one looks good. Second one looks bad. Third one looks like a mess, but I think it looks okay. And then the fourth one, no. The amplitude's 3, so let's look at this guy. And hopefully it'll allow us to zoom in on both of them. They look exactly the same, folks. Oh, it's 3 pi over 2 or something, I guess, maybe. So I don't think it's C. It looks like it's A. Are you kidding me? Is that a 3 pi over 2? I mean, am I going nuts? It has to be this one then. No, it can't be that one because it's not in the right interval. And these other ones are upside. Oh, cotan's always upside down. All right, sorry. Cotan always look. Sorry. So cotan always looks like that. So it's either B or D. And cotan, yeah, cotan, it goes through pi over 2. This one's going, looks like it's going through 0. So, sorry. 2 cotan. Okay, so x plus pi over 5 in between 0 and pi. So we have x greater than, so it's going to go from negative pi over 5 to pi plus pi over 5. So it's starting at pi over 5, negative pi over 5. Okay, so let's see if we can kind of identify that. I can zoom in. My eyes don't work very well anymore. It has an amplitude of 2, so that kind of looks like it's going through. It's going through 2. Let's look at this guy. Negative pi over 5. This one looks good. These are bad. These two are bad. Okay, so it's one or the other. I'm inclined to think it's the first one because the second one looks like it doesn't have an amplitude of 2. Looks like it's below 2 and then it's shooting up. So I'm going to say A. Okay. Use a graph. What is the equation of the reciprocal function? So this must be about cosecant. So use a graph of the following to obtain the graph of the function found by replacing sign with its reciprocal function. Give the equation of the function for the function that you obtain. I'm not sure what they mean by this. I'm just going to put cosecant in there and see what happens, okay? Sine of, oh, whoops, cosecant. I can't imagine they just want me to put cosecant there. That's just silly. X over 4, whoops, 4. Okay, right, so all we got to do is put the humps on top. There's going to be asymptotes here and here. Just have to make sure you pick the right one, I guess. Looks like it's A. It's A. Let's put the humps on there. Okay, cosecant guy. Graph 2 periods. Cosecant is kind of like the sine function. Sine of x over 2. Wedge x over 2. And multiply everything by 2. And then cut it into parts. So we're going by pi's apparently. 1 pi, 2 pi, 3 pi, 4 pi. Sine looks like this. And its amplitude is 1/2, wherever that is. And then our guy will go like this. Okay, so let's take a look. Ooh, the first one looks right. Is it A again? Is it always going to be A? Sure looks that way. Okay. This one's flipped, right? So we got 3 pi over 2x between 0, 2 pi. Multiply by 2 over 3 pi. And you get 0 less than x less than 2 pi over 1 times 2 over 3 pi. 0 less than x less than the pi's cancel. You get 4/3. Okay, so I need to divide that into 4 parts. I'll be going by 1/3, 1/3, 2/3, 3/3, 4/3. Again, it's a sine, but it's flipped. Amplitude 3, so it'll look like this. Okay. Oh my god, I gotta sneeze. Or this is 3. Okay, so it's going down. It looks like it's D. Yeah. And one more. Okay, secant is like cosine, so we're dealing with like cosine. X plus 4 pi over 3, wedge it. So we get 2 pi. There's a phase shift then. So you're starting at 4 pi over 3, and you're moving by the period over 4. So 2 pi over 4, looks like you're moving by pi over 2's. Common denominator, if you wish. Looks like it's negative 8 pi over 6 plus 3 pi's over 6. So what are we doing here? Negative 8 pi over 6 is way over here somewhere. 5 pi over 6, 2 pi over 6, 1 pi over 6. And we're dealing with a cosine function this time. So we'll go like that. The isotopes like this. Let's put in a little more detail. Going up like this, something down like this, right there, and amplitude of 4. So this will be at 4. Okay, so let's take a look. No, this is the first one, it looks like, but the amplitude isn't right. So C has the correct amplitude in the correct position. Okay, is that it? No, there's one more. Okay. Oh no, I'm done. I'm done. Okay, great. So that was pretty easy. Okay, you know, you're gonna have to do them by hand on the test, though. So okay, it's easy, but when I do up my review, I'll give you some question pool, and you can practice more problems in the book. Okay, but we're going to need some more practice to pull this off by hand. Okay, so anyways, thanks for watching, and we'll see you next time.